This problem and all other CALC 152 problems can be found here at Sarai Studies. Link is in the description box below. For this step, I see powers of n, so that immediately tells me root test, because root test literally comes with an nth root that I can use to cancel some of these out. So the root test is based on the limit as it approaches infinity of the nth root of the absolute value of your sequence, and whatever that limit is equal to, we actually call that rho, even though it's a p. So we pronounce it rho, but it's spelled rho. But the rule is, and I think of it as a number line, right? Negative, positive, so greater than, less than, and then no conclusions. So rho is less than 1, rho is greater than 1, and rho is equal to 1. Then as always, the first one is converges, then diverges, and then the last one is just no answer, try another test. But because we're dealing with root tests and ratios the same, we do converges absolutely. So let's just take the limit of the nth root of the absolute value of our sequence. So that's going to be 2n to the n over 3n times n to the fifth. But if you notice, the least that you're going to plug in is 1. So if you calculate, this is just 2 at the top, this is just 3, and this will always be 1. So it'll be 2/3 is the least that could ever be. So it will never be negative. So you don't need absolute values. So you can get rid of that. And then you can use your algebra rules. So you can split 2n to the n, and at the bottom, 3n to the n to the fifth. This you can even further split by doing this. Same thing over here. These n's cancel out and you're just left with n. These n's also cancel out, so you're just left with 3. And then here we can rewrite this as 2 to the first power, because there's a 1 there, and then divide it by whatever your root is, which is n, and then times n, and then divided by 3, and then times n to the fifth power divided by whatever is right there. And then if you plug in infinity, you'll get infinity over here, 3 times n, 5 over infinity. If you have one whole and you divide it into infinitely small pieces, that whole is going to get infinitely smaller, so small it's going to go to 0. Same thing over here. Anything to the 0 power is just 1. Same thing over here. Then we're just left with 3, and we're just left with infinity. Infinity over 3 is still just infinity. So this is our rho. Rho is greater than 1. So we say that our series diverges. For our conclusion, we say since, and then we literally just take the limit is equal to infinity, which is equal to rho, which is greater than 1. Then the root test implies that this series over here diverges. And that's it for this video. I'll see you in the next.